Hi there. Happy Wednesday. We are going to be covering watersheds today. Some of you may know me as Miss Cottle when I taught sixth grade math. Now I'm Mrs. Hennard and I am teaching sixth grade science. So like I said, we are going to get into watersheds. So today's objectives, we are going to be discovering or reviewing what a watershed is, Virginia's three main watersheds, what affects our watersheds, abiotic and biotic factors, water quality testing, and then we are also going to be doing an EnviroScape. Hopefully you should have a watershed map of Virginia, and you should also have a copy of notes, something to write with, and a piece of paper. So if you don't have those things, go ahead and just press pause, get those materials ready from your teacher. Or get out your science notebook and then press play when you have your materials ready. All right, so I'm going to share my screen. And I took pictures of my notes rather than going back and forth between the document camera. So hopefully you can see these. If you're not able to see them, I will do my best to make them as large as I can. But like I said, I'm going to share my screen. All right, so looking at this screen, I'm going to zoom in so you can see. Oops, wrong way. All right, it is not letting me zoom in anymore than 100%. So looking at this, like I said, you can pause this and record. It is not letting me make this any larger, but we have what is a watershed. The key thing to know here is that a watershed is a land area. It is not a body of water. It is a land area, also known as a drainage basin. All right. So a watershed in Virginia, like I said, we have 14. We have three major ones, though, and those would be the Chesapeake Bay, the North Carolina Sounds, and the Gulf of Mexico. It is also important to know that the Chesapeake Bay encompasses 6 different states. So we have Virginia, Maryland, Delaware, New Jersey, Pennsylvania, and New York. All right. And out of the Chesapeake Bay's watersheds or local watersheds, those not as major ones, the James River is the largest. All right. Some other watershed vocabulary is a divide. All right, so it's a high point, and I like to do my notes using a crossword puzzle style. If you can write it, you can use it. That's what I've always told my students. So when you log into your Science SOL, you can do a brain dump, and you can write down these 4 vocab words. You don't need to write down everything on your brain dump unless that's really what you've memorized. But knowing what a watershed is and knowing what a divide is and an estuary and a tributary will definitely help you out. So a divide is a high point, and it separates watersheds. So if I have a mountain and it's an area of high elevation, one side of that mountain might go to the James River. The other side of that mountain might go to the Gulf of Mexico. All right, 2 key vocab words that a lot of students get mixed up are estuary and tributary. So an estuary is a stream that meets at the mouth of another watershed. So it might be the James River meeting at the Chesapeake Bay because the James River has a mouth, or it could be the Chesapeake Bay meeting at the Atlantic Ocean. It's also important to know that it has tides. So you're going to have high tide and low tide. A tributary is a river that flows into another lake or river. All right, so this would be like the Appomattox River flows into the James River. The Swift Creek flows into the Swift Creek Reservoir, which flows into the Appomattox River. All right, so those are tributaries. Think smaller bodies of water. Estuaries are larger bodies of water, and they flow into the mouth. And again, they have tides. All right, we're going to come back to the water quality testing, so don't worry about getting all of that. But you can, like I said, press pause for the watershed, get all of those, press play. I'm going to stop sharing my screen now. All right, so we are going to look at a map of Virginia. I do want you to label your map and draw the divides of your map. They are pretty important. You can pause it to label it, and then I'm going to describe it, or you can just listen as you describe. All right, so looking at this map, we have 14 different watersheds in Virginia, and they're, like I said, they're already labeled for you, so you can just fill yours in. You should have a word bank. And then these dark gray lines I drew are the divides. Those are the highest points of elevation, not in this state, but those are the divides that are separating our watersheds. So everything to the west of this line is going to the Gulf of Mexico. So the New, the Yadkin, the Holston, the Clinch Powell, and the Big Sandy, those are all small watersheds in Virginia. They are all going to the Gulf of Mexico. Now, the New River is very interesting. It's one of the oldest rivers in the world, and it actually flows north, starts in North Carolina, flows through Virginia, and then into West Virginia, but it still drains to the Gulf of Mexico through the Mississippi River. All right, the Roanoke, Chawan, and Albemarle Sound, they all flow to the North Carolina Sounds. So the Abiotic Sound is that giant body of water. If you're on your way to the Outer Banks and you're almost there, you're already in North Carolina, you're going over the bridge, and you, like I said, it's a big body of water. That would be the Albemarle Sound. All right. So I just want to point something out really fast. These are not the size of the river. These are the size of the land area that drains to that river. Right? The James River is the largest watershed in Virginia, the largest local watershed, but this is not the actual size of the James River. It just means that all of these counties and cities flow to the James River and then into the Chesapeake Bay, which is our largest watershed. As you can see, it covers the majority of our state. All right, then we have the York River, the Rappahannock, and the Potomac Shenandoah watershed. So over here would be our Shenandoah River. Over here would be our Potomac River. And then we have the Chesapeake Bay Coastal Watershed. So that's one of our local watersheds, and part of it is from the main part of our state, and then part of it's from the peninsula on the eastern shore. And it just means that that water on this side of the divide flows directly into our Chesapeake Bay instead of going into a local river first. Same thing with the other side of our peninsula of the eastern shore. It flows directly into the Atlantic Ocean. All right. And what we can't see on this map is the full extent of the Chesapeake Bay. Remember, it covers 6 states. So above us, we have Maryland, and then we have Pennsylvania and New York. And then on the eastern shore over here, we have Delaware, and New Jersey's like tucked in right there. So those 6 states all feed into the Chesapeake Bay, which then goes out into the Atlantic Ocean. All right, so you can pause it to fill it in, or you can continue with me. I'm going to stop sharing. We're going back to this screen right here. All right, so far we've already covered what a watershed is, our largest watershed, which would be the James River, and then our largest major watershed, which is the Chesapeake Bay. All right. The next thing that we're going to get into is what affects our watersheds. So I'm going to go back to our notes, and I'm going to share my screen. Again, you can pause it to write this down. We're just going to copy these notes, and I'm going to describe them. All right. So what impacts our watersheds? We have 2 factors that really impact our watersheds, and those would be abiotic and biotic factors. So I want you to look right here at the root word and the prefix. All right. So bio means life or living. So biotic factors would be all of the things in our ecosystem or our environment that are alive. And then abiotic, the prefix a means not. Again, bio means living. So abiotic are the things that are not living, but they support life. So looking at our list, our biotic factors are plants, animals, bacteria, and fungi. Our abiotic factors are water, soil, sediment, air or the atmosphere, temperature, and sunlight. So all of our biotic factors need these abiotic factors to be at certain levels, or else our biotic factors could die. All right. And like I said, both of these things impact our watersheds. Our plants, if they are not enough plants, or if we have too many plants, especially algae, our watersheds could be unhealthy. If we have too many of a certain animal, our ecosystem could be unhealthy. If we have too many predators or too much prey, if we have a bacterial outbreak, our watersheds could be, toxic levels. And then same thing for fungi. If I have the wrong kind of mushroom in our environment, it could really throw things off balance. So all of those things could impact our water, or our water could impact them. All right. They have a symbiotic relationship. All right. So looking at our water, soil, sediment, air, atmosphere, temperature, and sunlight, we need those things to be at a certain range. So if I'm in a temperate climate zone like we are here in Virginia, I need our temperature to be pretty moderate. If I'm experiencing extreme weather, either cold or hot, it's going to kill off a lot of our plants and our animals. If I don't have enough sunlight, same thing. So we're going to talk about water quality, and we're going to talk about how these things could affect our biotic factors. All right, so you can press pause and get those things written down, or you can finish this page and we're going to come back to it. All right, we're going to watch a short video. All right, so now we're on the Chesapeake Bay Foundation, and you may have done some of these things with your watershed. What am I trying to say? Your watershed field trip in 6th grade, but I know a lot of us did not get to do that field trip. So if you did not get to go on that field trip, this is going to cover a lot of the testing that we did at the aquarium.
Hi everyone, I'm Claire Cambardella. I'm the Baltimore Harbor Environmental Education Program Manager for the Chesapeake Bay Foundation, and I'm out here today in Baltimore County where I'm going to be testing the water quality of my local stream. So what is water quality? It could be a number of different things depending on who you are and why you're asking, but it is a measurement of physical, chemical, and or biological characteristics of the water. And you could care about this because the water is going to be used for drinking, or because you're concerned about a certain population that is living in the water, or you could be concerned about how safe the water is for recreation. So the chemical characteristics of the water that I'm going to be looking at today include dissolved oxygen, which is the amount of oxygen that's dissolved in the water for fish and other invertebrate species that might be found falling around these rocks. The temperature of the water tells us a lot about the season, and also who might be out and migrating or hibernating. pH is an important chemical factor that controls a lot of other chemical factors. Nitrates and phosphates are the nutrients that downstream can unfortunately lead to dead zones in the main stem of the Chesapeake Bay. And then conductivity is something I'm going to be testing today because we're in a freshwater stream. So the first test that I'm going to show you is the dissolved oxygen test. And to perform this test, we use a YSI Pro 2030. And all I have to do is put a probe into the water, and I'll get a digital readout, which is pretty cool. And right now, you can probably hear the stream sort of bubbling behind me. And what I expect is that all this water movement is going to be putting a lot of dissolved oxygen into this water. So we'll see if my hypothesis is correct.
So here's our beautiful blowing stream. You can see I put the probe into the water, close to those riffles, but not directly in it. And again, I thought that our dissolved oxygen reading would be pretty high, but the Pro 2030 tells us otherwise. Our dissolved oxygen level is actually 5.7, which is healthy, but a little lower than I thought it would be in such a moving water stream. You can also see the temperature of the water there. It's 14.5 degrees Celsius, so it's still pretty chilly for this early spring.
So if you remember earlier, I said that moving water is more likely to have more oxygen. And here we're at this little waterfall, and I just couldn't help myself. I figured we might as well stop and check the dissolved oxygen level here too. As you can see here by this little waterfall, we've got a much higher level of dissolved oxygen. It's 9.22 to 24 milligrams per liter compared with our just barely above 5 milligrams per liter, just a little ways upstream. Okay team, now I'm going to test the pH of the water. And to do that, I'm going to use our trusty wide range Lamont kit. This is a pretty simple test. I just get to mix some chemicals together and compare the colors. Usually we want our pH to be somewhere around 7, which is neutral. So let's open this up. Inside we've got our color comparator, our test tube, and our reagent. So I'm going to fill this up. Add 10 drops. Alright, so let's see if we're anywhere near 7. Actually, looks like it's a pretty perfect match. So I'm going to say that our pH level today is 7. So I'm going to take a measurement of the level of nitrate in the water. And this level, along with the phosphate level, will give us an idea of whether or not there are excess nutrients in this water. And those excess nutrients can lead to algae blooms and dead zones later on down in the Chesapeake Bay. So I'm going to take these 2 test tubes and fill them up with stream water. I've put some chemicals into this test tube, and now I'm going to shake it for 1 minute. So now I have to let that color develop for 5 minutes. So I'm going to start another test. Now I'm going to test the phosphate in the water. And to do this, we use a colorimeter, which makes my job really easy.
All right, team, we want to see a phosphate level of less than 0.1. And today we've got a reading of 0.08, which is what we would consider to be in the healthy range. So this is good news. So we've come to the final step in our nitrate test here. And what I'm going to do is, you can see test tube B here. These are our test tubes. Test tube B has had chemicals added to it, which is reacting with the nitrate to turn the water that shade of yellow. And what I need to do is figure out which number here most closely corresponds to that color that test tube B has turned. So, nope. B is definitely darker than that top, so it's not 0. It's not 1. It might be close to 3. And maybe our closest match today is actually 5. So that doesn't mean that's our result. We actually have to convert that result to the concentration of nitrate in the water, which is going to be in milligrams per liter.
So just to quickly sum up our water quality results today, we've got a healthy level of dissolved oxygen, even though it's a little lower than I thought it was going to be. The temperature just tells us that it's springtime. pH is right at neutral, where we want it to be. Our nitrate level is a little high. The phosphate level is within a normal range. And then the last one, the conductivity, is also within the normal range. So that is normal in a range between about 150 to 500 microsiemens per centimeter. And that's actually a measurement of how fast an electrical current can travel through the water. And it tells us how much dissolved ions are in the water. And streams in urban areas can tend to have higher conductivity levels, which isn't natural for those streams. So that's why it's measured a lot of times in urban and suburban areas, and can give us an idea of stream health. So if I were going to be judging the stream health solely on the chemical parameters that we measured today, then I would say it's pretty healthy, but that the nitrate level is a little high. But remember, there are lots of other ways to determine the health of a stream. So we only looked at chemical factors, we only looked at one day. We also need to consider biological factors and physical factors as well.
All right, so that's just going to be part 1. There is going to be a part 2. So make sure that you watch both parts for the full lesson.